We're always hearing about AI, big data, machine learning, but today, we're going to pull back the curtain and talk about the invisible engine that makes all of that stuff actually work. It's called data mining. Let's get into it.
You know, this quote just nails it, doesn't it? We are creating an unbelievable amount of data every single second of every single day. But here's the thing. Raw data by itself is pretty much just noise.
So the real solution is to find the actual knowledge that's hiding inside all that noise. And that, right there, is exactly what data mining is for. It's the art of turning all that raw, messy data into real, actual insights.
All right, so first, let's just try to wrap our heads around the massive scale of this data flood and how data mining is our lifeboat. So at its heart, data mining isn't just one single thing. Think of it more like a super-powered team-up. It brings together machine learning, good old-fashioned statistics, and database technology to sift through these gigantic data sets to find hidden patterns we would literally never be able to see on our own.
Okay, but before we can go digging for gold, we kind of have to understand the dirt we're digging in, right? So what is data, really? Well, it turns out it comes in a couple of different flavors.
You can basically break down all data into two big buckets. On one side, you have quantitative data. That's all the stuff you can measure with numbers. It could be discrete, like a zip code, or continuous, like someone's height. And on the other side, you've got qualitative data. That's the stuff you categorize. It could be something nominal, like a color, or ordinal, which means it has a specific order, like A, B, C grades.
And this data doesn't just sit in a neat little spreadsheet either. It can be structured in all sorts of ways. It could be simple record data, yeah, but it could also be a super complex graph showing how your friends are connected on a social network. Or ordered data, like a stock price over time, or even spatial data, like a map. And each one needs its own special approach. Okay, so we get the data types, we know how they're structured. We should be ready to start mining for gold now, right? Well, not so fast. There is a huge, kind of hidden problem that every single person in this field has to deal with.
It's a problem that stands right between us and all those brilliant insights we're trying to find.
And here it is, the big secret. Real-world data is almost never clean and perfect. It's messy, it's chaotic, it is full of mistakes.
So what do we actually mean by dirty? Well, it can be incomplete, like a form with a bunch of blank boxes. It can be noisy, full of just plain wrong information, like a salary accidentally entered as a negative number. And it can be inconsistent, where the same person is called Bill Clinton in one place and William Clinton in another.
Now, I want you to get ready for what is probably the most surprising fact in all of data science. More than 80%, let that sink in, 80% of a data scientist's time is spent not on the cool, glamorous pattern-finding stuff, but on cleaning and preparing all this messy data. And that brings us to the most important rule of the game. It doesn't matter how brilliant your algorithm is, if you feed it garbage data, you are going to get garbage results. The success of the whole project really comes down to this one cleanup phase.
So how in the world do we fix this dirty data problem? Well, luckily there's a process for it, a methodical, four-step journey called data preprocessing.
This whole four-step process is really the unsung hero's journey of data science. First, you've got data cleaning, where you fill in the blanks and fix the obvious errors. Second is data integration, where you pull everything together from different places. Third is data transformation, where you get all your numbers onto the same scale. And finally, there's data reduction, which is about making the data set a bit more manageable without losing the important stuff.
This is a perfect example of why that first step is so crucial. See that one little data point way off by itself? That's called an outlier. And in that top image, it's completely throwing off the whole analysis. But look what happens in the bottom image. Once you deal with that one bad point, boom, the two real groups become perfectly clear.
Okay, so after all of that hard work, after that 80% of the job is finally done, we can get to the really exciting part, actually mining the data for those hidden patterns and telling a story with what we find. This is where the magic really happens. Just look at this raw data. To you and me, it's pretty obvious there are two C-shaped groups, right? But if you just throw a standard clustering algorithm at it without preparing it first, you get, well, that mess on the right. The algorithm is totally confused. It just cuts the data in half without seeing the real pattern.
But when that data is properly prepped, the same exact algorithm can now see the two groups perfectly. The mess gets transformed into meaning. And by using a simple visualization like this, the hidden patterns become crystal clear. This is the entire goal, turning that chaos into a story we can actually understand.
So I'll leave you with this one thought. The next time you read some big headline about a groundbreaking AI, I want you to think about the unsung hero of that story. The massive, painstaking, and absolutely essential job of data cleaning that made that whole discovery possible in the first place.